structured, then they will become functional proteins. So they become enzymes, they become structural proteins, they become transport proteins, okay, so on and so forth. So that is what happened in when polypeptides become matured and they become functional proteins. Okay, so I have the C terminal and the N terminal, meaning the carboxyl and the N refers to the amino group. Okay. Serine, phenylalanine, aspartame, or aspartic acid. So bonded together. So these are tripeptide bonds. Ammonia.
Sa amino, sa beta ay sa carbolic, ay sa carboxylic.
Amino, carboxyl, and then amino carboxyl. So ammonia, the peptide bonds. Peptide. So proteins behave as lighter ions. They all have an isoelectric point. At its isoelectric point, the protein has no net charge. Remember, at its isoelectric point, no net charge ang amino acids. So it's neither negative or positive. Okay? Now, at any pH above, meaning more basic, its pI, or say, its isoelectric point, it has a net negative charge. So kung basic gani class, ang iyang charge is negative. Kung acidic, positive iyang charge. Hemoglobin, for example, has an almost equal number of acidic and basic side chains. Ang iyang pI is 6.8. 6.8. Yang isoelectric point is 6.8. Almost equal number ang acidic o ang basic side chains. So murag kani almost positive, kani almost negative. Ang iyang mga iyang side chains. Ang hemoglobin. Now, serum albumin has more acidic side chains. Acidic yang isoelectric point. 4.9. Kani almost 6.8, almost 7, neutral.
2.2.
So that is the isoelectric point of hemoglobin. That's why it can interact. It can interact with, of course, namagod siya sa blood.
Hemoglobin case.
So it interacts with the acidic and the basic substances. Because of its isoelectric point equal to 6.8, almost neutral. Now, proteins are least soluble in water at their isoelectric points. Proteins are least soluble in water at their isoelectric points and can be precipitated from solution at this pH. So, kano sa siya mo precipitate? Ang protein, kano sa siya mo precipitate? That is when at its isoelectric point. So, a while ago, I projected the different isoelectric points and the different amino acids. At that time, it is least soluble in water if they are in its isoelectric point. So usually, it forms precipitation. Precipitate siya. Now, proteins can be classified based on their structure. Say, it could be a primary structure. When you say primary structure, now, the primary structure protein is said to be linear. It's linear. Straight lang. primary structure.
Primary structure is
The sequence of amino acids in a polypeptide chain lead from the N-terminal amino acid to the C-terminal amino acid. Straight. Straight. So, linear ang structure, that is primary structure. Now, like for example, insulin. We have some examples of primary structure. Insulin. They are arranged C-terminal or N-terminal is linear, straight. Then we have secondary structure. Secondary structure is said to be helical. Helix, beta-pleated, sheets, and random coil, meaning helical, like that. Helical. Like that. That's helical. Secondary structure. Now, tertiary structure is the complete three-dimensional arrangement of atoms of a polypeptide chain. So, tertiary, usually, okay. Now, quaternary is globular. Dagko, highly globular. Okay. Spatial relationship and interactions between subunits in a protein that is more than one polypeptide. We have some specific example here. This is the primary structure. Example, as what I have said, insulin. Linear. Linear yang structure. So it's composed of the following amino acids. So we have here our insulin. Okay? They're held together by two interchain disulfide bonds. So straight lang siya. Okay? Now, you are very familiar with insulin, right? So if you become diabetic, the next thing there is you'll be injected with insulin. It could be that what made you diabetic, it's because maybe your beta cells in the islets of Langerhans of your pancreas would no longer be producing insulin. So there should be a synthetic insulin that would be injected that would facilitate in the transport of glucose in the blood to the cells. So the role there of insulin is to activate the GLUT4, which is the glucose transporter in the cell membrane. So once it is activated, so it serves as the key that activates this GLUT4, so it will be opened up for the transport of glucose. So from the blood to the cells, so that it will be used up as energy. Okay? Now human insulin consists of two polypeptide chains having a total of 51 amino acids. The two chains are connected by two interchain disulfide bonds. So here it's this is a study actually comparing the structure of insulin in human, cow, hog, and sheep. Now take note of the chain positions. So like this is the A chain and the beta chain. Remember, ang insulin natay A chain, diri natoy beta chain. So of course, they are linear. Now, here's the A chain sa human, asay pari-pariho og sequence sa amino acid. Okay, baboy.
Oh my gosh.
So mamaw sa A chain. Sa beta chain, sa human, wala so far. And that makes us unique. Fortunately. But more or less, usually the source of our insulin, they take that up from hogs because of this sequence of amino acids in the A chain. Threonine, serine, isoleucine. Okay, so pare-pareho sa baboy. Okay? Okay, another example of primary structure is vasopressin. Now, vasopressin and oxytocin are both non-apeptides or non-apeptides but have quite different biological functions. Now, vasopressin is anti-diuretic or ADH. Now, another term for ADH is vasopressin. Yeah.
DDH.
Anti-diuretic hormone. That's the other name for vasopressin. Now, what is that anti-diuretic hormone? Okay. Now, the anti-diuretic hormone regulates as to how much water is retained in the kidneys. Or say, how much will be retained in the kidneys and how much will go back to the circulation. So that is anti-diuretic hormone.